Hello and hi. We are structural design team of SA Consultants Sdn Berhad. We are proposed to design and build 6-story office building at Ibu Pejabat Lembaga Lebuh Malaysia, Wisma Lebuh Kajang, Selangor, Darul Ehsan. We are required to design 6-story office building by using the STAAD PRO software. This is our base design with the dimension of 30 meter times 100 meter with the story height of 4.5 meter. The horizontal wind of our design is 30 kN acting laterally and full height of the building at both direction of the building with slab loading of 15 Newton per millimeter square. The loading condition of our group is point load 5 kN at B2, D2, B10 and D10. The modulus of elasticity of our design is 205 kN per millimeter square. We are using STAAD PRO software as I mentioned before to design the 6-story office building, starting with plotting the nodes based on the building dimension to creating beams from the nodes to another. We created 6-story off-row structure before we key in all the requirements required by the client. This is our overall property. We had chose American wide flange beams, also known as W shape, with the designation of W18 x 158. And for the columns of the structure, we use British universal beams, or also known as UB shape, with the designation of UB 914 x 305 x 224. For our support property, we had used the fixed support that were installed on every node on the lower slab of the building. Next, we proceed with the load cases details of our design. There are 4 loads were installed to the structure. As you can see, we have wind load. We had wind acting Z direction with intensity of 0.7 kN and also wind acting X direction with the same intensity, both acting to the whole height of the building. Next is point load. We were required to install 4 point load at B2, B10, D2 and D10, all of them with 5 kN each. For third load case, slab loading was installed with the pressure of 15 Newton per millimeter square acting downward. Last load case will be self-weight. The self-weight acting on the structure wholly was installed with the factor of 1.2 acting downward, while also having weight endured by all the column with 0.5 kN load acting downward also. So here is basically the load cases details of our design. Next step is we analyze the structure to see whether there's any error with the design that we've made. And this is the analyzed data that we have done, and we came out with 0 errors and 0 warning for our structure.
After we had analysed the structure, we did the utility checking to determine the critical extreme beam with the highest actual ratio nearest to 1. As you can see, the green light shows that there are no failed members can be found on the structure. So the critical beam that we determined is beam 65 with an actual ratio of 0.929, that is approximately to 1. So as far as you can see, in the table are all the forces acting on beam 65. More details will be explained using the graph that has been plotted. So now moving on to the graphs. For the first force, which is wind in Z direction, as you can see, there are no moment and forces seems to be affected beam 65. Same goes to wind X, and also point load acting at B2, B10, D2 and D10. However, for the slab loading, the many moment diagram curve started from 704 kN and it goes down to negative 407 kN, but the forces only Y direction seems to be affected, which started at 343 kN and goes down to negative 343 kN. As for south weight, the curve for many moment diagram started at 22.9 kN and goes down to negative 11.5 kN. And the forces in also affected in only in Y diagram. So our Poisson is 0.3 and our density obtained that is 7,833.37 kg/m3, and this also is our physical properties. The elasticity obtained by us was nearly 205 kN as required, hence the small difference was negligible. So this is our whole structure in 3D version. Further explanation can be read in our report that was prepared by us. So thank you for watching. Have a great day.